The frame opens on a winter-quiet control room. Screens dimmed to the cool of early morning. The air full of the tiny sounds of machines that never sleep. On one monitor, a star is nothing but a white pin. Yet below it, a thin line of plotted light gently steps down, holds steady, then climbs back to where it was. That small dip has no drama to the naked eye. No fireworks, no chorus. It is the kind of change only instruments can love. But it is also the signature of a world crossing a sun. We can measure the timing. We can measure the depth. We can compare second pass to third. And the rhythm holds. A planet exists where, a year ago, there was only assumption. Multiply that by thousands, and you earn the right to feel the universe is crowded with places to stand. Yet every radio receiver we have built leans into the dark and brings back weather, static, and the innocent crackle of natural forces. If worlds are common, why is conversation so rare? If chemistry keeps starting fires, why do they not light cities? The paradox is a door we can touch, and it is locked. We walk toward the door with what we can carry, and what we carry are devices. A small photometer bolted to a concrete pier that remembers every breeze. A spectrograph that stretches the spectrum until motion shows up as a lean toward blue, then a lean toward red. A telescope planted far from wet air, and one that sits above the wet air entirely. A dish carved from a valley. A mirror that must be kept so cold that your breath would crack it if you got too close. These are not adornments of curiosity. They are the method by which the universe is convinced to speak. One measures shadow. One measures tug. One tastes thin air across an impossible distance. Together they keep us honest. They also keep us aware of how little we can force. Consider a picture you can hold in your mind. The museum after hours. The lights are off. The galleries are locked. The exhibits are unmoved. Outside, the city runs as it always has. Inside, there are rooms full of detail that none of that city can see until morning. We are not the city in this image. We are the night staff. We have keys. We have a flashlight. We have the obligation to record what we see without disturbing what we see. We move the beam in slow stripes. Here, a fossil in glass. There, a bronze with a surface like old river stone. At the edge of the light, labels wait to be read. But the beam is narrow, and our time is finite. The feeling is not emptiness. It is responsibility. If the museum seems empty, that is a property of our lighting, not of what is kept inside. In the control room, we return to the dip in light. Another team, in another building, checks the same star for motion toward and away. A world's pull is not much, but the star admits it if you listen long enough. The numbers quarrel at first, then they settle down and agree. And agreement is the closest thing we have to truth in a sky this large. We start to draw an orbit, then we fit a size. Temperature comes next, with the humility a distant thermometer demands. It is only a sketch, but it is honest work. We put the new world on a list with others, and we let the list change our sense of scale. There is a census being made in the dark. Simply put, a small drop in starlight that repeats tells us a planet is there and how it moves. A small stagger in a star's spectrum tells us that planet has weight. When both line up, we trust the reality more than we trust our hopes. We can do this again and again across the sky because stars are steady clocks and light, for all its speed, is obedient to patience. If this sounds spare, that is because spare is reliable. Spare is what survives the test of a second instrument. We do the spare thing across a variety of strange places, close enough to photograph. A moon where rain is not water falls into lakes of a fuel we would not dare to cup in our hands. A far cold world that should be asleep shows signs of heat moving under a crust you could mistake for stone. A red desert teaches a small machine to pull breath from thin air. None of these prove a neighbor, but each proves that the universe does not mind bending the rules we grew up with. Storms do not require warmth from a bright sun. Heat does not require a core like ours. Air does not require the kindness of a biosphere to be useful to a traveler. The picture grows more complicated, which is to say, more real. In everyday language, we have thick evidence that planets are ordinary, and no evidence that anyone else speaks. That is the core of the hook. Every new curve of light that matches a careful period reinforces the first part. Every quiet night at a listening dish reinforces the second. The two facts coexist without mercy. The feeling this produces is not despair. It is attention. Attention is the resource that makes a method. We could retreat to easy stories. We could say that intelligence is a fever that burns itself out. We could say that communication is a luxury evolution rarely buys. We could say we are early, or late, or in a bad neighborhood. We could build fictions to ease the pressure of a sky that will not nod back. Or we could stay with the data and its disciplined reach. That reach is the promise of new eyes that can separate the colors of a planet's day from the colors of its night, the breath of its sky from the roar of its star. When that separation is clean, a molecule will betray itself by swallowing just the photons it favors. If the spectrum is clear enough, we will name the molecule. If the history is long enough, we will see its seasons. At its core, this is a problem of reading, not of shouting. The museum is not listening for us. It is guarded by physics, not policy. So we learn to read better. We practice calibration until we can trust the faintest differences in a light that was old before we were born. We practice subtraction, taking out what is ours, then what is the instrument's, then what is the stars, until the remainder has the shape of a world. We keep our one metaphor on a short leash. No lighthouses, no orchestras, no planets wearing crowns, just rooms, darkness, and the narrow honesty of a flashlight. There is a second set of numbers that does not fit in the window of a single night. These numbers stretch across seasons and orbits. They are the kind that reveal a world's climate, not just its geometry. If a planet inhales in summer, we might see a trace of that in the way the light leaving its day side changes. If a planet exhales in winter, we might see that in the way the light crossing its night side speaks in slightly different tones. This is right at the edge of what we can do. It asks us to build instruments we can barely imagine, and to give them a space where the heat of the sun is a rumor. The price is large. The payoff is a reading, not a revelation. Think of it like this. The exhibit labels we need are printed in a faded ink that only shows up when you look from the exact angle, and our flashlight has to be steadier than a heartbeat to hold that angle. We can know the room exists, we can feel its dimensions, we can say foreign words about its contents, but we will not claim what we cannot read. The discipline is the value. It protects us from ourselves. What about the old idea that maybe the silence is not an absence at all, but a consequence of civilization and scale? A culture that learned to manage heat and motion at continental levels would, in this imagining, rearrange the ways a world throws light back into space. If that rearrangement is large, we might notice. If it is careful, we might not. People have drawn scales of power to rank what is possible. Those scales are thought experiments, but they are also measuring sticks we can lay against the sky. If a star dimmed not by a planet but by an architecture, and if that dimming changed with reasons other than orbit, we would have reason to ask new questions. For now, the reasons we see have natural clarity: clouds, dust, cold. To put it another way, if there is a party in the museum, either it ended long ago, or it is happening in a wing where our keys do not fit. That uncertainty is not a flaw in the search. It is the search. We act as if patience is not weakness. We build the next instrument to lower the noise floor below a threshold that used to be called impossible. We teach ourselves to be comfortable with the idea that we might not be the audience for every message that exists. In the meantime, we practice being good guests in rooms we can reach. On the red world, a fist-sized box has learned to make a breath out of thin air. It is not enough to fill a suit. It is enough to prove that chemistry works the same here as there. In orbit, a thin golden mirror learns to unfurl without a human hand to guide it. It learns to hold still against a universe that, on the largest scales, is very much in motion. On our own ground, a line of small lenses moving in lockstep turns a patch of atmosphere into an observatory, then another, until we can tile a sky with attention. None of this is dramatic to the untrained eye. All of it is the correct answer to the question, what comes next? We return to the paradox and find it unchanged. Many worlds, no neighbors. The mind wants to put a name to a wall it cannot see. Some propose a filter that most lines of life cannot cross. Some suggest that filters come in sets, and that only one or two must fail to erase a broadcast. Others say the filter might be behind us, already passed, which would make the silence a relief rather than a warning. These are not arguments we will settle tonight. They are scaffolding we can use to decide what to measure: the presence or absence of a kind of air, the presence or absence of a world that keeps its heat too well, the presence or absence of wild disequilibria that have no good natural story. What this means is that the open loop remains open on purpose. We will not force it closed. We will follow a thread that runs from counting worlds, to reading their light, to visiting in mind the few we have photographed, to training ourselves in the basics of staying, to evaluating what sort of evidence could make silence make sense. Along the way, we will keep the metaphor simple, because simplicity is the only real defense against fantasy. The museum after hours, our flashlight, our notes, our obligation not to break what we are studying. At the human scale, this is how it feels. A scientist walks down a hallway humming quietly so as not to disturb the numbers. A technician warms their hands on a mug while a cryopump sighs in a room that must never see daylight. A student, tired enough to make mistakes, checks one more calibration, then one more, learning the patience that keeps a field honest. Somewhere, a dish on a dry plateau turns a little and waits. Somewhere, a mirror breathes evenly in a chamber that is colder than any mountain night. This kind of work is not a race. It is a vigil. A vigil is a kind of respect. We will respect what we do not know by commanding what we can. We will map. We will detect. We will test. We will measure. We will reveal. Carefully. We will verify. We will compare. We will follow. We will explain. The verbs are plain because the task requires that they be. The story, in that simplicity, becomes larger, not smaller. By keeping our promises small, we keep the possibility alive that, somewhere in the patterns, a larger voice will appear without our needing to invent it. And if no voice appears for a while, then we will have learned how to read the rooms well enough that, when one does, it will not be a trick. We will recognize artifacts of nature because we have cataloged them. We will recognize the work of time because we have watched it. We will recognize signal because we will have trained ourselves not to hear echoes as more than echoes. The path is slow, but it is real. The paradox remains pressing, and that pressure gives the path its shape. We will now lift our eyes from the control room and walk the museum deliberately. First, the gallery where we count, because counting is how you begin anything you wish to understand. Then the gallery where shadows and tugs become measurements of mass, radius, and alignment. Then the gallery of longer light, where cold eyes can tell air from glare. Then the rooms with photographs of weather that does not care about sunlight. Then the rooms with ice that moves heat like a secret machine. Then the workshop where a handful of oxygen is pulled from a hostile sky. Then the hall where the silence is weighed against the scales of energy. Then, at last, the door with the word message written small on the brass. If this journey adds clarity, please like and subscribe. To the Quiet Universe channel, we begin the census in earnest, starting with how we count other homes by the dimming of distant suns. A telescope on the plateau turns its mirror toward a modest patch of night. The sky above is so clean that even the faintest star keeps its edge. Inside the control hut, there is little motion. only the faint hum of a cooling system and the metronome click of data packets leaving for a server half a world away. The observers are not expecting fireworks. They are waiting for subtraction. Each image, each hour, each week removes the ordinary from the extraordinary until what remains is the small, repeating fall in light that means a planet has crossed between its star and us. That fall is all the census needs. When it happens again, the pattern becomes a person in the registry. Not a name, not a face, but a presence. We call these dips transits. A star brightens and dims, and the dimming repeats with a rhythm no random storm could mimic. It is an old idea, and a humble one, that an absence of light is itself a kind of signal. If the timing matches, we know something solid, something with gravity, interrupted that light. The data looks like a heartbeat, each pulse a planet, each steady interval a year somewhere else. The beauty of this method is its blindness to fame. It does not care if the star has a myth attached to it, or if the world has a romantic name. It cares only about timing, depth, and repetition. In plain terms, astronomy began keeping books. The list grew quickly. Every new instrument doubled what we knew. A telescope on Earth handed the baton to another above the atmosphere. Satellites mapped one patch of sky until they memorized the flicker of every star in it. They sent back millions of light curves, and in that flood, patterns whispered through. Some of those patterns were mistakes. And that is part of the discipline. Noise likes to dress up as meaning. The only cure is repetition. When the same dip appears in different seasons, in different cameras, with the same interval, then we accept the record as real. The census has no shortcuts. It pays in patience. From those first patterns, we learned that planets are not rare ornaments, but common features. Worlds larger than Jupiter. Worlds smaller than Earth. Worlds so close to their suns that their years are measured in days. It became clear that nature builds excess into her designs. The catalog reached thousands, then more, until the word exoplanet sounded less like a frontier and more like a fact of geography. Each line on the list came with a probability, a margin of error, and a mood. Some entries felt solid, others ghostly, waiting for better instruments to confirm or erase them. The important thing was not certainty, but abundance. It is hard to fear loneliness when the directory grows this fast. We do not see the planets themselves. Not at first. We see their shadows, and from those shadows we draw outlines. With the brightness and timing, we can deduce the size. With the shape of the curve, we can guess the orbit's tilt. If the host star's color is known, we can estimate the world's temperature. From these numbers, we build portraits of places that no light has yet painted. A world the size of Neptune, but scorched. A super-Earth with a day so short it must roar with wind. A mini Jupiter circling a dim sun like a lantern around an old campfire. The diversity is dizzying, and that dizziness feels honest. Nature does not repeat patterns unless forced. A second method checks our work. It listens for the wobble of the star itself, a tug forward and back as if a dance partner were shifting weight. The wobble writes itself into the star's spectrum, a small lean toward blue, then a small lean toward red. This motion confirms mass. Combine the transit's size with the wobble's pull, and we know density, which is to say we begin to know composition, rock, gas, or something in between. Two pieces of indirect evidence make a whole. When both agree, the world becomes real enough for us to give it weather in our models. Why does this matter? Because every step in this arithmetic is a rehearsal for seeing ourselves from afar. If someone on another world were measuring our star, they would see our light dip by less than 1% every time Earth crossed. They would see that dip repeat every 365 days. From that alone, they would know a small, warm planet circles a stable sun. They could guess it has air. They could imagine a chemistry complex enough to be interesting. We have become the mirror of that imagination. To count others is to imagine being counted. The census has its paradoxes. Some stars host chains of planets packed tight, almost touching. Others show only one. We expected regularity, but nature delivered chaos that somehow balances itself. The orbits are tilted, the masses strange, the alignments improbable. Yet the systems endure. The lesson is sobering. Stability does not require simplicity. Survival does not require perfection. That may be the most human lesson the exoplanet era has given back to us. At its core, counting planets is counting failures of our early assumptions. We thought solar systems would resemble ours. We thought giant planets would always live far from their suns. We thought small ones would always be quiet. Instead, we found hot Jupiters swinging so close to their stars that they deform from heat. We found rocky worlds large enough to crush iron into new phases. We found planets in binary systems that should not have allowed stable orbits at all. The universe, it seems, enjoys correcting us. Our best response is to listen longer. Simply put, we have traded stories for statistics. Where myth once placed a single heaven above, we now map many. The census does not ask for beauty, yet beauty keeps arriving. The more worlds we add, the more patterns we glimpse: metallicity favoring planet formation, star age correlating with orbit spread, the gentle line where habitability could begin. Each pattern is tentative, each subject to revision, but together they make a landscape worth walking. You might ask, what can these distant numbers do for us? They recalibrate humility. When we see that nature repeats the architecture of systems across the spiral arms of the galaxy, we understand that our address is not exceptional. That truth can either shrink or enlarge us depending on how we hold it. For scientists, it enlarges. To be typical means our experiments are universal. To be one of many means our questions are shared. At the human scale, a single transit is a line of pixels dropping fractionally in brightness. To the eye, it is nothing. To the mind, it is a handshake across trillions of kilometers. Students check those pixels one by one, removing artifacts, noting the faint regularity, feeling the thrill of an object that will never know them. The universe does not need to answer to be intimate. What this means is that a census is also a mirror. Every time we count another world, we practice counting the conditions that made our own. Every new orbit extends the grammar of the possible. There is comfort in that, and a hint of duty. We will need this data when we start to look closer, when we begin to read atmospheres as sentences instead of hints. For now, the act of counting is the story. The story is that abundance is normal, and normal is enough to wonder about what comes next. The census now complete for this patch of sky. We turn the mirror toward a new question: how to read the shadows more precisely and find the faint signals that mark the next step in our search. The second gallery in the museum opens with darkness. The lights rise only enough to show motion, a shimmer of reflected metal, the slow pivot of a telescope larger than any cathedral. The mirrors face a field already mapped by the census. We know which stars host shadows. Now we want to know what those shadows mean. The instruments change. Instead of watching for a simple dip in brightness, we start dissecting the light itself. Every color carries a story. When a planet passes, some colors fade more than others. The missing pieces in that rainbow are chemical fingerprints. In those absences, we read the composition of air. The first spectra arrive thin as whispers. They need to be stacked, averaged, and corrected for the breathing of the instrument itself. After months of patience, the graphs settle into shapes we can trust: sodium, water vapor, carbon monoxide. All appear in lines across the plot. They are not proof of life, but they are proof of weather. Weather is a kind of motion, and motion means energy. And energy means the possibility of chemistry that refuses to rest. To detect that from hundreds of light years away is the first act of intimacy between us and them. At its core, this is not discovery in the romantic sense. It is verification. One group observes a planet's shadow, another measures its star's wobble. The combination gives us both size and mass, and from those we derive density. A low-density world is a gas giant. A high one is rocky. Some are so dense that their cores must be made of metals we can only form in laboratories. Others are so light that they must be full of hydrogen. Between these extremes is a zone of curiosity. Planets with densities that suggest oceans of ammonia, or carbon dioxide snow, or atmospheres so thick that sunlight never reaches the ground. In plain terms, we are watching stars shake in response to invisible partners. The motion is tiny, meters per second, but our instruments have learned to hear it. A shift toward blue when the star moves closer, a shift toward red when it moves away. Add up thousands of these shifts and you have a rhythm, the beat of an orbit. When several planets circle the same star, their beats interfere, creating patterns that reveal how they pull on one another. From that tangle, we deduce stability, age, and sometimes the hint of an undiscovered companion. The wobble is a voice of gravity, soft but persuasive. Why does this matter? Because it turns distant points of light into physical worlds with measurable weight. It replaces imagination with equation, myth with mechanics. We are no longer guessing what might be out there. We are measuring what is. This precision allows theory to stand trial. Models of planet formation must now explain the orbits we actually see. Theories about migration must account for hot Jupiters hugging their stars. Every wobble and every dip is evidence entered into that court. The methods improve with patience. Instruments that once drifted now hold steady for years. Lasers keep spectrographs honest. Clocks on Earth sync with clocks in orbit. Every improvement carves another decimal into the confidence of our measurements. And yet, precision alone is not enough. We need imagination disciplined by math. When data looks strange, we must ask whether the star itself, not a planet, caused the change. Stellar flares, spots, or pulsations can mimic planetary signs. A careful observer must separate the actor from the stage lighting. That separation is an art learned over decades. Think of it like this: to detect a planet by its wobble is like noticing a dancer's partner through the movement of the dancer's shoulders. Even when the partner is hidden behind a curtain, you cannot see the partner, but you know someone must be there. The tempo, the sway, the recovery between steps all betray the unseen presence. Astronomy is learning to read the shoulders of stars. Sometimes the stars deceive us. Binary systems create wobbles too large to belong to planets. Flares add false colors to spectra. Dust between us and the target dims light unpredictably. We build algorithms to compensate, but algorithms have biases. The cure is diversity of method. If one telescope sees a signal, another must confirm it through a different approach. Parallax, astrometry, direct imaging, all are parts of the cross-examination. Only when several witnesses agree do we write a planet's name in ink instead of pencil. At the human scale, this verification looks less glamorous than the headlines. It means long nights recalibrating sensors, checking fibers for temperature drift, comparing archived spectra for subtle shifts. The excitement lies in small victories: a stable baseline after a storm, a clear absorption line where before there was noise. Each confirmation deepens the map of reality. The reward is cumulative, not explosive. We have learned that some stars are better subjects than others. Small, cool dwarfs show deeper transits, easier to read. Bright, massive stars are noisy and unstable. The choice of target shapes what we can learn. We select quiet suns, those whose flicker is gentle, whose rotation does not confuse our timing. Around them, Earth-sized worlds can hide without being erased by glare. The process resembles a doctor choosing where to place a stethoscope. Listen at the wrong spot, and you miss the heartbeat. Simply put, astronomy's progress depends on restraint. The instruments are now so sensitive that they can detect motion smaller than a human walk. Brightness changes smaller than a candle seen from the moon. Such sensitivity tempts us to claim more than we should. The discipline is to wait for confirmation, to let skepticism be the parent of belief. Science advances not by what it declares true, but by what it refuses to call false too soon. Each wobble adds to the symphony of statistics. With thousands recorded, we start to see patterns. Massive planets tend to form quickly, close to young stars. Smaller ones require time. Metal-rich stars breed complex systems. There is logic under the apparent chaos, but it is probabilistic, not absolute. For every rule, an exception waits to be discovered. That balance keeps the field alive. In everyday language, this is the moment when counting becomes listening. The light tells us not just how many, but how they move. Motion is history made visible. A tilted orbit hints at past violence. A world kicked out of alignment by a sibling. A circular one suggests peace. Time enough for atmospheres to settle and seas to form. We are reading family dramas written in wavelengths. Human-scale questions follow. If a distant observer applied the same test to our sun, what would they learn about us? They would see Jupiter first, its mass tugging the star enough to be obvious. They would detect Saturn, maybe even Neptune. Earth would be harder, its signal buried in noise. They might infer that small rocky planets exist, but not know which one carries liquid water. Our own signature would be faint. That realization humbles us. We are learning to detect others before we can even be sure how detectable we are. At its core, the study of shadows and wobbles is the study of interpretation. Instruments record the facts, but humans decide what those facts mean. Two teams can look at the same data and draw different conclusions. One sees a planet, another sees stellar activity. Only time and repeated measurement resolve the argument. This slow arbitration is the cost of certainty. The universe rewards persistence more than brilliance. What this means is that discovery has turned into a long negotiation between signal and doubt. Doubt is not the enemy. It is the filter that keeps imagination aligned with reality. Every confirmed world is a victory over noise. Every retracted claim is proof that honesty still guides the field. The blink of a distant sun, properly understood, is as trustworthy as a handshake. We can build on it. Why it matters should be clear now. Each new confirmed world tightens our models of how systems evolve. That in turn informs where we look for habitable conditions. The better we know the rhythm of a star, the better we can subtract its noise and isolate the thin spectral lines of gases that make life possible. Without this groundwork, the search for biosignatures would be chasing ghosts. The discipline of measuring wobbles is the foundation of all future revelation. To put it another way, we are teaching ourselves to listen before we speak. The temptation to send messages grows every year, but listening must come first. The lessons of false positives, of mistaken wobbles and misread shadows, apply equally to the ethics of communication. We must be sure what we hear before we assume who it is from. As instruments become colder, larger, and steadier, the blinks of distant suns become pages in a growing book. Soon, with the newest telescopes, we will read those pages in the infrared, where molecules speak more clearly. The difference between a barren world and a breathing one may be a single line in that spectrum. To read it, we must silence our own noise. That is why the next generation of instruments will orbit far from Earth, away from heat and chatter. The quieter the detector, the louder the universe. The blink of distant suns is the slow language of truth. It demands years of patience, years of silence, and the humility to be corrected by light that left its source before our species learned to build. Yet within that language lies the next step, the promise that chemistry, seen through wobbles and shadows, can lead us to the scent of life itself. We have learned how to weigh the unseen. Next, we must learn how to see through glare, to separate the glow of a star from the faint breath of a planet that orbits it. The night above Earth is not as still as it looks. Even from the ground, the air trembles with temperature and moisture, bending the starlight until it flickers. To the human eye, this shimmer is beautiful. To the scientist, it is noise. To see further, to see truly, we must rise beyond that moving veil. The early telescopes in orbit were our first escape attempts, small metallic rooms that learned to stare without blinking. They taught us that clarity is altitude, and altitude is silence. Now, as we build newer observatories, the goal is not just to climb higher, but to see deeper, to look at wavelengths the human eye never evolved to notice. Where visible light fails, infrared begins, and there the cosmos hides a second truth. The great mirrors are built for this darkness. Their shapes are thin but vast, petals that unfold with mechanical grace once freed from gravity. They float at points where the pull of Earth and Sun cancel into balance. There they remain almost motionless, cooled until even the heat of their circuits fades below the warmth of deep space. Around them, a faint haze of dust, debris, and faint solar wind whispers past, unseen. The mirrors do not care. They collect what the universe throws at them, light stretched by distance and time, radiation softened by the expansion of everything that ever was. What they return is not an image, but a map of energy, coded in temperatures just a few degrees above absolute zero. At its core, this new generation of instruments extends our eyes into the cold, where optical telescopes see stars. These see the glow of dust that shelters new suns. Where ordinary cameras see black, infrared sees construction sites of galaxies. The same sensitivity that reveals ancient light can also study nearby worlds, those whose stars drown them in glare. A trick called coronography hides the star's center, creating an artificial eclipse that allows the faint orbiting glow of a planet to emerge. To find a single dot beside a beacon is not easy. It requires control finer than heartbeat and stability better than any human hand could manage. But when the star's light is masked, a world can appear a crescent, a smear, or sometimes a full disk reflecting enough warmth to be measured. Simply put, we have built night vision for the cosmos. The mirrors see heat, not light. They see through dust, not around it. They translate what would be darkness into color that the mind can process. In that translation, new terrain appears disks of gas around newborn stars, knots of matter collapsing toward ignition, and the soft signatures of atmospheres on planets already known. What was once statistical, the catalog of worlds detected by shadows, becomes visual. We can confirm their existence not by subtraction, but by sight. The first images are humbling. A giant planet glows like an ember beside its sun, orbiting too far for transit methods to catch. Another system shows multiple rings of dust, each carved by invisible planets, like grooves on a record left by fingers that have long since moved away. Every new observation rewrites a chapter of our understanding. The universe seems more elaborate the closer we look, but also more consistent. Dust makes stars. Stars make planets. Planets make storms. The cycle repeats. And in the repetition lies design without designer, order without script. Why does this matter? Because for the first time, we can compare light from different layers of reality, the bright visible glare of a star, the infrared whisper of a planet, and the microwave echo of the universe's oldest fire. We are starting to connect scales that once lived in isolation. The same physics governs all of them, and by tracing that symmetry, we trace our own origins. To know how light behaves at every temperature is to know where chemistry can flourish, where energy can hide, and where life might persist unseen. In everyday language, we have learned to look with two kinds of eyes, one for the near sky, one for the ancient. The near sky tells us what is now. The ancient tells us what has been. By overlapping the two, we can begin to predict what will be. This is not fortune-telling. It is the mathematics of time seen through wavelength. When a telescope like the JWST looks at a young star and sees carbon dioxide in the atmosphere of its planet, it is witnessing a potential future, a stage that could lead, given patience, to complexity. To look in infrared is to look in potential. There is a human-scale drama beneath these cosmic vistas. The engineers who designed the unfolding mirrors had to bet everything on reliability. There would be no repair missions, no second tries. Every hinge, every circuit, had to work the first time in the cold of space. When the mirror finally opened and light began to pour into its instruments, a silence fell across the control room. It was the silence of relief, of an entire generation watching a concept become a functioning eye. That moment defined what deeper means, not just distance, but trust in our ability to extend perception into realms where we can never stand ourselves. Think of it like this: a mirror does not think. It only reflects, but when you build one large enough and cold enough, reflection becomes revelation. You are not merely seeing, you are seeing how seeing itself works. The faintest photon becomes a clue, the softest shadow a sentence. You learn that the universe is patient with those who watch it carefully. And in that patience you find a kind of companionship, silent but steady. These telescopes do more than photograph. They dissect. Each photon's energy is measured, categorized, and stored. The patterns they find are fingerprints of molecules, minerals, and motion. One world shows methane in its air. Another hints at water vapor. Some display signs of carbon chains that could, in the right conditions, form the scaffolding of life. We do not jump to conclusions. The history of false alarms has taught us restraint, but even restrained, the excitement is real. Each detection is a small bridge between speculation and observation. At the same time, new questions rise. How many of these readings are universal? Does every young system go through a dusty adolescence? Does every giant planet migrate inward before settling down? Are we catching a single phase of a much longer process, or a unique arrangement that will never repeat? The data hints, but it does not answer. Astronomy, even with deeper eyes, remains a conversation half complete. In plain terms, what these machines teach us is humility sharpened by capability. They do not grant omniscience, they grant perspective. They remind us that every gain in vision comes at the price of distance. Every new wavelength we open isolates us from what we used to know. But that is the pattern of growth, for species and for science alike. You lose the comfort of the familiar to gain the truth of the real. At the human scale, one can imagine standing under the night sky after a power outage. The city dark, the horizon clean. The stars look brighter, closer. The feeling that arrives is not possession, but belonging. The same feeling drives the design of instruments that will never see home again. They belong to the dark, they were built to interpret. The engineers call them eyes. But they are more like ambassadors, sent into a realm where human senses cannot follow, carrying our curiosity as a cargo of code. Why it matters is simple. Every refinement in seeing changes what we consider ordinary. The first infrared images of distant planets made it clear that heat is not confined to proximity. Even in the cold, energy finds ways to persist. If warmth can travel this far, perhaps life can too. The distinction between habitable and barren becomes thinner, more conditional. The line moves outward with every improvement in detection. Each time we learn to see deeper, the border of possibility expands. To put it another way, we are no longer prisoners of visible light. We have joined the company of wavelengths that existed long before eyes. The universe has been shining in infrared since the first atoms cooled, waiting for someone to notice. In finding that signal, we complete a circle. We are the product of light, now teaching light how to describe its own past. That feedback loop is poetic and practical at once. It lets us verify the age of stars, measure the spread of dust, and model the growth of complexity that might lead to life elsewhere. As these telescopes watch, their detectors fill with evidence of storms beyond imagination. On some worlds, clouds of silicate glass flash like sparks. On others, metallic rain falls sideways in magnetic fields. Each scene challenges what we thought weather could be. Yet in every case, physics holds. The laws we discovered here apply there. That is comfort disguised as astonishment. It tells us that the universe is not arbitrary. It has rules, and those rules favor structure, repetition, and endurance. In the control rooms on Earth, the screens display color-coded images that no human eye could directly see. Red means cooler, blue means warmer. But in truth, the wavelengths are far beyond either. We translate to make sense. Just as a musician transposes to match the range of the instrument, the translation is beautiful, even if approximate. What matters is the consistency. When a pattern repeats across instruments and missions, it becomes a fact. Facts, in this sense, are the art of agreement. We can now measure the glow of planets not just in reflected light, but in their own thermal emission. That glow reveals their rotation, their seasons, and their albedo. Some worlds spin quickly, spreading heat evenly. Others are locked, with one side scorched and the other frozen. Each type tells a story about balance, about how systems negotiate energy. These lessons echo backward. They remind us that Earth's own climate is not permanent. It is a negotiated peace among forces that care nothing for our preferences. At its core, deeper eyes show us not the exotic, but the familiar, reflected back at larger scale. Every dust ring, every moving shadow, every pulse of heat mirrors something close to home. Seeing them changes how we value what we already have. To look at a distant storm is to recognize the physics that sustain our own weather. To read the infrared of another atmosphere is to appreciate the fragility of ours. The act of seeing becomes an act of gratitude. We have now learned to pierce the veil of glare. The next step will be to dive beneath the surface of other worlds, to study not their light, but their chemistry, the strange rain and slow tides that make them more than dots on a map. The scene opens in twilight orange. A haze drapes over a world larger than Mercury, colder than any desert night. This is Titan, Saturn's largest moon, where the light is perpetual sunset, and the air is thick with chemicals that would kill us, yet might one day teach us how life begins in the absence of warmth. It is a place where methane reigns, where rivers run not with water but with liquid hydrocarbons, and where the ground crunches under a snow of frozen organic dust. To look upon Titan is to confront an inversion of everything we call familiar. Cassini approached it with the reverence of a guest arriving uninvited. The spacecraft's orbit around Saturn allowed dozens of flybys, each one dipping closer into the heavy atmosphere. From the first radar echoes, it became clear that Titan's surface was not the solid ice once imagined. There were lakes, hundreds of them, clustered near the poles. Some were as large as Earth's Great Lakes, but their composition was alien methane and ethane-filling basins carved by rain and erosion. The moon had weather, seasons, and storms. It was, by every mechanical definition, alive with movement. At its core, Titan is an experiment already running, a chemistry set the universe built long before we arrived. Sunlight too weak to melt ice still manages to split methane high in the atmosphere, triggering reactions that cascade down into complex organics. Those particles drift like smog until they fall, a slow, orange snow that blankets everything. When it rains, that chemistry washes into the lakes, creating mixtures rich in carbon and nitrogen. These are the same elements that, on Earth, formed amino acids and proteins. The difference here is the temperature. At 180 degrees, reactions slow to the crawl of geological time, yet they do not stop. Simply put, Titan is the cold laboratory of creation. Everything we think of as necessary for life, heat, oxygen, liquid water, is missing, yet the ingredients of complexity persist. What this means is that life's chemistry might be more flexible than we dared to believe. It may not need to copy Earth's recipe exactly. It could function in another solvent, move through another pace, breathe another rhythm. The boundaries of biology are not fixed. They are hypotheses waiting for data. The Huygens probe, a small descent capsule released from Cassini, confirmed the landscape firsthand. As it fell through layers of haze, its instruments recorded wind, temperature, and pressure. The data told a story of dense air and gentle descent, more like floating than falling. Near the surface, the cameras switched on. The images revealed rounded pebbles of ice, evidence of erosion by a flowing liquid. A riverbed, the first seen beyond Earth. Then the signal faded as Huygens touched down on a plain of damp sand and froze in silence. Its mission ended there, but the message was permanent. Titan has an active cycle of weather, drainage, and sediment. Think of it like this. Titan is a mirror held up to Earth, but the reflection is reversed. Where we have water, it has methane. Where we have oxygen, it has nitrogen. Where our clouds shimmer white, its sky burns copper. Yet the structure, the system is the same. Evaporation, condensation, rain, runoff. The same choreography, performed at a different tempo. Nature does not change the dance, only the dancers. Why does this matter? Because Titan proves that planetary processes can mimic one another even when the ingredients differ. It is the ultimate argument against provincial thinking. If chemistry can sustain such elegance at temperatures that freeze breath itself, then the definition of habitable must widen. We used to think life required the warmth of a star like ours. Titan whispers otherwise. Perhaps warmth is only one path among many. In everyday language, Titan shows that a planet does not have to look like home to behave like home. Its dense atmosphere shields it from radiation, allowing stable weather. Its gravity holds the gases close enough to create long-term equilibrium over millions of years. That balance could lead to molecules that learn to replicate, not quickly, but steadily. There is no proof yet, only suggestion. But in science, suggestion is the seed of exploration. The surface itself is carved by forces both gentle and violent. Radar images reveal dunes that stretch for hundreds of kilometers, shaped by winds that never stop blowing. Valleys wind toward the polar seas, carved by liquid methane the way rivers on Earth carve limestone. Some regions show bright patches that appear and disappear over time, likely rainfall events captured in real time by orbiting eyes. Titan breathes, slowly but visibly. At the human scale, imagine standing there. The sky would glow amber, the horizon blurred by haze. The ground beneath your boots would crunch with frozen hydrocarbon sand. A drizzle would fall that never wets your skin, because it evaporates into vapor before touching warm flesh. You could not breathe, but you would see waves lap against icy shores. The sound would be muffled, the air heavy, carrying the faint chemical tang of fuel. The experience would be eerie and calm, like walking inside a dream you cannot fully wake from. At its core, the science of Titan is the science of analogs. We study it not only to understand itself, but to glimpse early Earth. 4 billion years ago, our world might have looked similar, haze-rich, oxygen-poor, dominated by organic chemistry waiting for a spark. Titan freezes that stage in time, preserving it for observation. To look at Titan is to look backward at what we once were, and sideways at what might have been if heat had never arrived. To put it another way, Titan holds a memory of possibility. Its chemistry has not advanced to biology, but it has not stopped trying. In laboratory experiments, scientists simulate Titan's atmosphere by mixing nitrogen and methane under ultraviolet light. The result is Tholin's complex organic solids that form spontaneously. On Titan, these tholins fall like rust-colored snow, layering the ground in raw material. No spark, no life. Yet the pieces wait. The implication is subtle, but powerful. Life may not need miracles, only time. Simply put, Titan teaches patience. The universe does not rush complexity. Where Earth achieved speed through heat, Titan balances longevity with cold. The same chemical alphabet is written slower, more carefully, as if rehearsing the words without yet speaking them. This slowness is a form of wisdom. It reminds us that life is not inevitable, but persistence is. Why it matters extends beyond curiosity. Understanding Titan's chemistry helps us predict what we might find elsewhere on Neptune's moon Triton, on Pluto, even on exoplanets with similar temperatures. If Titan's weather can recycle organics without destroying them, then other cold worlds could be reservoirs of prebiotic matter, waiting for a change in conditions. The cosmos might be full of paused beginnings. At the human scale, Titan's allure is emotional as well as scientific. It challenges the myth that warmth equals safety. It suggests that beauty can exist in silence, that motion can be slow but sure. To explore it is to expand empathy for what is alien. The probe that landed there became our first footprint on a world colder than nitrogen frost. Yet even that single print changed the story of the solar system. We realized that our neighborhood is not a chain of barren stones, but a family of active environments, each with its own rhythm. What this means is that our concept of habitability must evolve. Titan is not alive in any sense we can measure, but it is alive in behavior. Its rainfalls, its rivers carve, its seas reflect sunlight in glints that look eerily like the shimmer of oceans at home. The distinction between chemical and biological blurs at such fidelity. The moon behaves like an organism that breathes methane and dreams in nitrogen. At its core, Titan's story is a reminder that exploration is self-reflection. By mapping another world's processes, we rediscover the ones that sustain us. The carbon in Titan's haze is the same carbon in our breath. The molecules that build its dunes once built our ancestors. Chemistry is the thread that ties the cold and the warm, the alien and the human, the now and the beginning. To put it simply, Titan invites us to imagine life without comfort, beauty without sunlight, and persistence without haste. Its rain may never touch a living cell, but its pattern speaks of endurance. We measure it not because we expect to find ourselves there, but because it shows what the universe can do with the same ingredients, rearranged under different laws. The lesson Titan leaves is one of balance. Heat is not the only teacher. Cold can instruct just as deeply. In the slowness of its reactions lies a record of potential, waiting for the right spark or the right warmth, perhaps millions of years from now. And if that moment never comes, Titan will still have written its hymn to chemistry in every drop of methane rain. We now leave Titan's amber skies and drift farther outward, toward a smaller, lonelier world where heat hides beneath ice and motion takes the shape of a heartbeat frozen in nitrogen stone. The light of the sun reaches Pluto as a whisper, faint enough that shadows have no sharp edges. From this distance, daylight feels like the glow before dawn on Earth, weak and bluish, spread thin across a plain of nitrogen frost. For most of human history, we imagined Pluto as an inert shard at the edge of the system, frozen solid, a relic too far away to matter. Then, in July 2015, a small spacecraft crossed that darkness and replaced assumption with image. New Horizons showed us a world alive with scars, plains, and strange movement in ice world that refuses to be still. The photographs were not static postcards. They revealed something breathing beneath the surface. The great heart-shaped plain, Sputnik Planitia, stretches across half a hemisphere, a basin of frozen nitrogen miles thick. Its surface is divided into polygon cell-like shapes dozens of kilometers across. Each cell is a window into a slow current warm ice rising at the center, cold ice sinking at the edges. This convection takes place at temperatures below -200 degrees Celsius. Ice, under pressure and patience, behaves like rock, and rock, at these scales, flows like a liquid. Beneath the crust, heat is moving. Simply put, Pluto is not dead. It runs on a slower clock. The heat that stirs its interior comes from the decay of radioactive elements trapped in rock billions of years old. That decay is mild compared to the burning core of Earth. Yet in a world so well insulated by ice, even a trickle of warmth becomes power. The result is geological motion without sunlight, a circulation of frozen matter that reshapes the surface every few million years. What we thought was ancient terrain is young, perhaps younger than human civilization. Think of it like this. Pluto's heart beats once every eon. The convection cells rise and fall like slow breaths. Cracks at the edges mark the places where nitrogen ice dives downward. Fresh ice wells up from below, erasing craters and painting the surface smooth again. No other body this small shows such vitality. The contrast with its neighbors cold, cratered Charon, or distant Eris suggests that Pluto has an internal rhythm all its own. It is less a corpse than a sleeper, turning in dreams we are only beginning to interpret. Why does this matter? Because Pluto shatters the assumption that size dictates life. Even at the edge of the sun's warmth, even with a diameter smaller than the moon's, there is enough energy to drive change. Where energy moves, chemistry follows. Beneath the crust of nitrogen and water ice may lie a hidden ocean, kept liquid by pressure, salts, and residual heat. Models suggest that this ocean, if it exists, could be tens of kilometers deep, sealed under a lid of rock-hard ice. In the language of planetary science, possible is a word worth gold. At its core, this hidden heat rewrites the boundary between active and dead worlds. Pluto's tectonic scars, vast rifts running hundreds of kilometers, show that its crust has expanded, as if something inside had warmed and swelled. That something could be water turning to ice, or gases thawing into bubbles. Either way, the surface testifies to motion beneath. Craters cut across older rifts but are erased on younger planes, proof that the planet's skin is constantly recycled. Even here, at the edge of darkness, geology refuses to freeze completely. In everyday language, Pluto reminds us that warmth has more than one source. The sun is not the only engine. The universe hides smaller fires, radioactive decay, tidal friction, chemical reaction. These quiet energies are enough to stir whole worlds if they are patient. The same principles that drive Pluto's heart may operate on moons like Europa or Enceladus. Life, if it exists there, would owe its persistence not to sunlight, but to the chemistry of endurance. Pluto, in this way, becomes a lesson in subtle power. When New Horizons flew past, its instruments traced the thin thread of Pluto's atmosphere, mostly nitrogen, with faint traces of methane and carbon monoxide. The atmosphere extends hundreds of kilometers above the surface, forming hazy layers that catch sunlight and scatter it into blue. As the spacecraft watched, some of that air escaped into space, stripped away by solar radiation. The loss is slow but steady. Every wisp that escapes tells us the planet is changing, evaporating grain by grain. Yet below, new gases still seep upward, replenishing what is lost. The cycle turns over, endlessly fragile, endlessly renewed. At the human scale, imagine standing on the edge of Sputnik Planitia. The horizon curves slightly, low mountains rise like frozen waves, and the sky glows faintly with twilight that never ends. You could hear nothing but the soft settling of frost. Under your feet, molecules of nitrogen shuffle and squeeze, transmitting the faint warmth from below. It would feel like standing on the surface of a sleeping creature, aware of its slow pulse through the soles of your boots. The distance from the sun would not seem like absence, but like privacy. To put it another way, Pluto's story is not about exile, but persistence. It keeps moving despite neglect. It was demoted from planethood by human definition, but the planet itself never noticed. Its processes continued. The data from New Horizons forced scientists to restore its dignity not by title, but by complexity. It belongs to a class of worlds that bridge categories not planet, not comet, not asteroid, but something in between, carrying the physics of all three. Simply put, Pluto is the bridge between inner heat and outer cold. It proves that motion can come from decay, that structure can arise from scarcity. The heart-shaped basin, bright and young, may have formed from the impact of a large object billions of years ago. That impact would have released heat, melted the crust, and perhaps seeded the ocean beneath. Over time, convection rebuilt the plain, erasing the crater, leaving only the soft outline of a heart, a scar turned into a symbol. The image captured humanity because it mirrored us, fragile, wounded, enduring. Why it matters extends beyond geology. The processes that keep Pluto's interior warm echo the early Earth. Our own planet once relied on similar radioactive heating to power volcanoes and plate tectonics before the sun's stability took over. By studying Pluto, we see what happens when that internal furnace runs on minimal fuel. We learn how thin the line is between alive and asleep in planetary terms. Understanding this line helps us predict where subsurface oceans might exist elsewhere and which ones might have lasted long enough for biology to begin. At the human scale, every bit of data from Pluto feels like a whisper across an impossible gulf. The radio signal from New Horizons took over 4 hours to reach Earth. By the time we saw the first images, the spacecraft was already beyond the planet, heading for deeper targets. In that delay was a metaphor we see the past. Always. Light and information travel slower than our desire. Exploration is a form of nostalgia, the attempt to catch up with what has already happened. Think of it like this. Pluto is a pressure cooker buried in snow. Inside, slow reactions continue, invisible from above. The ingredients are simple water, ammonia, rock, but under confinement they exchange heat and momentum, keeping the world's core just warm enough to move. If the crust cracks, gases rush upward, refreeze, and create geysers that leave dark stains across the surface. These stains are Pluto's handwriting, brief eruptions of memory on a planet that otherwise speaks in silence. At its core, the persistence of heat beneath Pluto's ice changes how we define habitability. It suggests that even the most distant worlds can harbor pockets of liquid, and where liquid exists, chemistry follows. We no longer confine the possibility of life to the narrow ring around a star. The frontier has expanded to include the cold, the faint, the overlooked. Pluto, in its frozen dignity, is part of that expansion. In everyday language, Pluto's lesson is endurance without audience. It proves that beauty does not need to be visible to be real. The planet's orbit carries it in and out of sunlight over centuries, yet its inner heat never quits. The convection beneath its surface outlasts human lifetimes. This is a kind of hope quiet, geological, slow. It tells us that even when surface light fades, energy persists in hidden forms. Why it matters on the cosmic scale is simple. When we understand Pluto, we understand the architecture of resilience. We see how small bodies recycle heat, how gravity, chemistry, and time conspire to maintain motion long after the fireworks of formation have ended. The faint warmth that rises through Sputnik Planitia is the same principle that keeps deep ocean vents alive on Earth. It is continuity disguised as frost. The truth is that every world has its own metabolism. Some burn fast and bright. Some pulse slowly in the dark. Pluto belongs to the latter kind. It teaches us that the universe values duration as much as brilliance. The heart beneath its ice beats on. Not for us, not for recognition, but because decay, gravity, and persistence are rules no distance can break. The spacecraft that revealed Pluto is still moving outward, carrying our curiosity past the known frontier. Behind it, Pluto turns, unhurried, its surface renewing in silence. Somewhere beneath the nitrogen plains, heat rises like memory through layers of time, and beyond it waits another chapter, another experiment in endurance, a red world close enough for sunlight, where we will try to breathe the thin air and make it our own, make it our. From orbit, Mars looks deceptively familiar, a dusty cousin of Earth, scarred and quiet, draped in a thin veil of cloud. The surface is red, not because it burns, but because it rusts. Iron oxide covers everything: dunes, mountains, ancient seabeds. The air, what little there is, would suffocate a person in seconds. It is 95% carbon dioxide, less than 1% oxygen. Standing there without protection would feel like gasping through a hole in the wrong universe. And yet, Mars pulls at us with the promise that we might one day fix this imbalance, that we might find a way to breathe where no lungs were meant to. The dream of Mars is not conquest. It is reciprocity, the idea that we can give back to a planet what it has already taught us. Every rover that crawls across its plains, every orbiter tracing its thin atmosphere, carries a single question disguised as many: can we make air here? Not air in tanks, but air in the open. Air that grows from the soil and sky itself. For the first time, that question is more engineering than fantasy. Simply put, Mars has the ingredients of breath, but in the wrong order. The planet's air is rich in carbon dioxide. Split one molecule, and you free oxygen. That chemistry is simple on paper, brutal in practice. The temperatures are low, the pressure thin, the dust invasive, yet within this challenge lies an invitation to invent. The Perseverance rover carries a golden box called MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. It is no larger than a car battery, but it performs a miracle of scale. It pulls in Martian air, compresses it, heats it until the bonds of carbon dioxide break, and releases oxygen as a byproduct. Every time it runs, the output is small, a few grams, enough for a breath. But a breath is how every life begins. At its core, MOXIE is a rehearsal. It is not meant to supply an astronaut. It is meant to prove that a factory of such devices could. The principle is electrochemistry, but the spirit is adaptation. Mars has given us fuel for thought, an entire world waiting to be reconfigured by patience and care. Each successful oxygen run is a declaration that habitability can be engineered, not just discovered. Think of it like this. Breathing on Mars is not only a biological act, it is a philosophical one. It means learning to live by rearranging what exists instead of importing what we miss. It is the same lesson that plants learned on Earth billions of years ago when they began turning sunlight into air. We are imitating their art, building photosynthesis out of circuits and heat. If the experiment succeeds, the boundary between biology and technology will blur, and a planet will begin to exhale. Why does this matter? Because Mars is the first place where survival and ethics will share a single breath. To live there, we must balance invention with respect. We must decide how much of the planet to change, how much to leave untouched. Terraforming, the idea of making Mars more Earth-like, sounds powerful, but every action carries weight. Release too much heat, and the atmosphere might escape faster than it forms. Introduce new microbes, and the record of ancient life, if it exists, could vanish under contamination. The moral dimension of air begins here. In everyday language, we are learning that breathing on another world is a conversation, not a command. Mars does not yield easily, and that resistance is valuable. It teaches restraint. The thin air tests every human assumption about comfort and dominance. To breathe there, even through a machine, will mean understanding limits as intimately as possibilities. The landscape of Mars tells us why the task is hard. Once, rivers cut canyons deeper than the Grand Canyon, and deltas spread like ancient handwriting. Long ago, Mars had a thicker atmosphere and surface water, maybe even oceans. Then its magnetic field collapsed. Solar wind stripped the air, and the oceans evaporated into space. What remains is a skeleton of weather dust storms that wrap the planet for months, frost that gathers at dawn, and winds that whisper through empty craters. The air that remains is both a warning and a gift. It shows us what happens when a planet loses its shield, and what can be rebuilt if we learn to make our own. Simply put, Mars is the perfect classroom for endurance. The sunlight is strong but distant, the temperatures harsh but predictable. These are conditions that test ingenuity rather than destroy it. We know how to protect machines from radiation. Now we must learn how to sustain breath. Future habitats will need greenhouses sealed tight, plants that recycle air faster than we can, and systems that can fail gracefully instead of fatally. Every design begins with a single equation: how to turn carbon dioxide into oxygen faster than we consume it. At the human scale, the first colonists will live inside pressurized domes, each breath a manufactured privilege. They will hear the hiss of oxygen generators the way sailors once heard the creak of masts. Air will be currency. Waste will be resource. They will build rituals around maintenance, because survival will depend on it. And outside those domes, the wind will keep shaping dunes that have waited billions of years for footprints. To put it another way, Mars demands humility disguised as ambition. The planet is neither hostile nor welcoming. It is indifferent. And indifference is the truest test of will. To breathe on Mars will mean learning to be small again, to earn every inhale through diligence. That is not conquest. That is participation. Why it matters is simple. Every step we take toward making air, there strengthens our understanding of air here. Earth's own atmosphere is changing under our hands. Studying how to generate oxygen from carbon dioxide on Mars is a mirror of what we must do to preserve balance at home. Space exploration, at its most honest, is planetary therapy, a way to study ourselves from the outside. At its core, the science of oxygen on Mars extends beyond chemistry. It touches psychology. A breathable atmosphere is more than pressure and gas. It is permission to stay. The moment humans can fill their lungs on another world, even for seconds, the concept of home will expand. The frontier becomes personal, not abstract. We will no longer visit space. We will inhabit it. Think of it like this. Breathing is the simplest rhythm, the first and last act of life. To breathe on another planet is to teach that rhythm to the cosmos itself. The machines that separate oxygen from carbon dioxide are metronomes keeping time between worlds. They hum quietly, drawing order from chaos, promise from dust. When the first astronaut stands outside and inhales air made entirely from Martian resources, that sound, the intake of breath, will be the loudest silence in history. At the human scale, every molecule produced by Moxie represents collaboration between Earth and Mars. It is the planet's own air, recycled through our ingenuity. The red dust that once seemed sterile becomes part of the life support system. The chemistry is literal, but the symbolism is not lost. We are transforming alien air into a shared language. Why it matters in the long run is that this experiment changes exploration from extraction to symbiosis. We will not survive by bringing everything with us. We will survive by learning to use what we find. Mars is the rehearsal for that shift. When we perfect the art of breathing there, we can apply it anywhere: icy moons, exoplanets, even ships between stars. Breathing becomes an engineering principle, not a gift. In everyday language, learning to breathe on Mars is learning to stay calm in the face of magnitude. The planet is a teacher with no voice, its lessons written in dust and silence. Every problem solved their oxygen, shelter. Heat is a page in a manual on how to be adaptable species. Survival is the syllabus. Curiosity is the grade. At its core, the effort to make air on Mars binds together science and meaning. Each experiment affirms that our reach does not have to destroy what it touches. Each molecule of oxygen produced is a vote for coexistence between intelligence and environment. The act of breathing, repeated across 2 planets, becomes a bridge of empathy in chemical form. What this means is that the red world will test more than our machines. It will test our restraint, our ethics, and our patience. If we succeed, Mars will not just host humans, it will host responsibility. The first breath taken there will belong to everyone who ever dreamed of expanding the circle of life without breaking it. We will leave Mars's domes with that breath still echoing, and turn our instruments back toward the night sky, where a deeper question waits in the silence. If we can breathe here, why is no one else breathing anywhere? The further we look, the stranger the quiet becomes. Our telescopes have cataloged thousands of stars with planets, many in zones warm enough for liquid water, many old enough for life to have evolved and matured. Yet the receivers, tuned to the widest range of frequencies, record only static. There are no repeating beacons, no coded pulses, no celestial Morse tapping out a greeting. This contradiction has a name, the Fermi paradox, though the puzzle itself is older than the question. If life is common, where is everyone? At its core, the paradox asks whether absence is evidence or illusion. We know the galaxy is ancient and fertile. We know chemical complexity arises everywhere dust and gravity meet. If intelligence is not unique to Earth, it should have had time to fill the galaxy with signs of itself. The silence is therefore unnatural, or we are listening wrongly. It forces two possibilities, both heavy that we are alone, or that others are choosing not to speak. In everyday language, the problem can be stated simply. The math says we should see them. The sky says we don't. To bridge this gap, we invented explanations filters. We call them points in evolution or technology where most civilizations stop. A great filter can lie behind us, meaning that life's emergence is nearly impossible, and we are one of the few to pass. Or it lies ahead, waiting to erase those who reach a certain stage. Either way, the silence becomes a message survival is not guaranteed. Think of it like this. The galaxy is an ancient library, but most of its shelves are empty. Maybe the books were never written. Maybe they burned. Maybe the readers learned to whisper. Each filter is a theory about what went wrong, or what went right only once. The first filter could be biological. Perhaps the leap from chemistry to self-replication is so improbable that it happened here and almost nowhere else. Titan's frozen patience and Pluto's slow chemistry remind us how delicate that spark might be. Molecules can linger for eons without combining into systems that copy themselves. If the odds are astronomical, then Earth's success was not guaranteed but accidental, a dice roll won against entropy. The second filter might be ecological. Life begins, but stability ends. Planets near their stars burn, planets far away freeze. Atmospheres erode, and magnetospheres collapse. Mars tells that story in red. It had air, then lost it. If most habitable worlds follow that curve, civilizations could rise and fall before they learn to reach space. They would vanish like breaths on glass, leaving no trace except the chemistry of decay. A third filter could be technological. Intelligence might carry within it the seed of self-destruction, weapons too powerful, climates too fragile, algorithms too persuasive. A species may build tools faster than it builds wisdom, burning through its chance to persist. The record of Earth in the 21st century is an early test of that filter. Our survival or failure will measure whether intelligence is adaptive or terminal. Simply put, the great filters are mirrors, each reflecting our fear in a different tone. Behind them lies humility, the reminder that progress is not protection. The universe may be filled with beginnings that never learned how to continue. We, standing on one small world, are old enough to imagine the silence, but young enough to be part of it. Why does this matter? Because the silence shapes how we search. If we expect noise and find none, we might miss quieter kinds of signals, infrared heat from vast machines, rhythmic dimming from engineered clouds, or the unnatural smoothness of orbits sculpted by intention. If the filters are real, the survivors, if any, would learn discretion. They would choose invisibility, communicating only in subtle rearrangements of light. We must learn to read restraint as language. At the human scale, the idea of filters touches emotion more than theory. It evokes an unease older than astronomy, the fear of being unheard. A child calls into a canyon, waits for the echo, and hears only wind. That is our current condition. The canyon is wider than imagination, and the echo may take millennia to return. Yet we keep calling, not because we expect an answer, but because the act itself defines us. At its core, The great silence might not be an absence of voices, but an abundance of caution. Civilizations that survive long enough to master energy might also master discretion. Broadcasting power across interstellar distances is an act of vulnerability. Any signal bright enough to be heard could also invite response from the unknown. Perhaps wisdom teaches quiet. A galaxy full of wise beings could therefore sound empty. To put it another way, the silence might be civilization's camouflage. We are animals of noise, addicted to visibility. But a mature intelligence could learn that survival requires patience and low volume, like deep-sea creatures that glow only briefly to mate or feed. Cosmic cultures might communicate in bursts too rare for our brief observation windows to catch. The quiet then becomes not emptiness, but etiquette. Simply put, time itself is a filter. A signal from a distant world may have passed Earth before our species learned to listen. Another may still be en route, centuries from arrival. When we say no one is speaking, what we mean is no one is speaking now. The galaxy's conversation might span tens of millions of years. We are new guests who have just walked into the room. Why it matters is because the filters, real or imagined, reframe our place in cosmic history. If the hardest step is behind us, the origin of life, then we are a miracle. If it lies ahead, the survival of intelligence, then we are a warning. Both interpretations demand responsibility. Either we guard what is rare, or we prove that rarity can endure. In everyday language, the Great Silence is an education in humility. It reminds us that knowing how to detect life is not the same as deserving to meet it. Before we expect neighbors, we must ensure we can live with ourselves. This shift from expectation to introspection may be the hidden purpose of the paradox to make self-awareness a prerequisite for contact. Think of it like this. The filters are less walls than mirrors, placed at milestones along a road. Each reflects a different version of civilization: young, reckless, wise, extinct. When we peer into the next mirror, we are not looking forward, but inward. The reflection that answers determines which side of the filter we stand on. The search for extraterrestrial intelligence. SETI operates under these metaphysical shadows. Arrays of radio dishes sweep the sky, converting silence into data. Most nights they find nothing but cosmic background and the chatter of our own satellites. Still, the effort continues. Hope becomes method. Every null result refines the map, tightening where signals are not. Absence sharpens curiosity. At its core, this persistence is what defines a civilization capable of passing filters, the ability to continue despite disappointment. The Great Silence is not discouragement. It is the background against which patience acquires meaning. If we ever do hear a signal, a narrow spike of coherent radio, a mathematical pulse, a mirrored structure orbiting a distant star, it will not erase the silence but make it comprehensible. We will understand the gap as prelude. Why it matters beyond science is that the paradox offers moral gravity. It cautions us to measure power by endurance, not by expansion. If civilizations vanish when they grow too loud, then modesty is survival. If they vanish when they grow indifferent, then curiosity is salvation. In both cases, listening is the wiser act. At the human scale, the Great Silence mirrors our smaller silences, the spaces between generations, between species, between ideas. To keep calling across those gaps is to affirm connection itself. The act of searching for others becomes indistinguishable from the act of preserving our own coherence. To put it another way, we may already be the noise someone else hears faintly, wondering if it is natural or made. We could be another civilization's faint whisper at the edge of detection. The paradox then folds back on itself, turning us from listeners into participants in a dialogue that began before we evolved. Simply put, the great filters might not be punishment, but preparation. They select for endurance, ethics, and empathy. If we pass them, it will not be because we shouted louder, but because we learned to survive longer. That is the silent wisdom written across the void persistence as the only reply worth sending. The silence remains, vast and complete, but within it we are building better ears, better questions, and gentler ambitions. The next step is not to demand an answer, but to test what kind of voice we should use if one finally arrives. And from this quiet reckoning, we turn to the last experiment to speak deliberately, to craft messages not as noise but as invitations, and to decide what kind of story we wish to send into the dark. The story of communication with the cosmos begins not with technology, but with longing. Before radio, before the mathematics of waveforms, humans used fire, mirrors, and drums to signal across distance. Every method depended on the same fragile hope that someone, somewhere, was watching for the same rhythm. When we turn our transmitters skyward, we are repeating that ancient gesture with different tools. The scale has changed, but the impulse is the same. We are creatures that cannot resist reaching across the dark. The first deliberate messages sent into space were modest, pulses of radio coded in binary, patterns too simple to mistake for nature, too deliberate to ignore. They carried greetings, chemical formulas, the basic shapes of atoms, the outline of our solar system, and a sketch of humanity's stick figures drawn in mathematics. Later came records carved with sound greetings in dozens of languages, music, laughter, the whisper of waves. The Voyager records, drifting since 1977, are now further from the sun than any human artifact has ever been. They spin through the void like bottled letters cast into a cosmic sea. At its core, every message we send reveals as much about our fear as our curiosity. The universe is silent, but not necessarily empty. To speak first is to take a risk. A message is also an exposure, a confession of coordinates, a proof of existence. Some scientists argue we should keep listening and not transmit at all, that broadcasting could invite unknown consequences. Others argue that silence is cowardice, that a species capable of self-awareness owes it to the cosmos to introduce itself. The debate is less about science than philosophy, whether the moral instinct of intelligence is to announce or to observe. Simply put, the question is not just what to say, but whether to say anything. Once a signal leaves Earth, it becomes irreversible history. It will travel for millennia, moving outward long after our languages have evolved or vanished. Any answer, if it comes, will reach a civilization different from the one that sent the message. When we speak for humanity, we speak for a future we will never meet. Think of it like this. Sending a message to the stars is like unlocking a door without knowing who built the house. It is an act of hope and of vulnerability. The key works both ways. We may find understanding or intrusion, yet every open door in science began with a similar risk. The first astronomers who used telescopes were accused of arrogance for looking too far. The first navigators who sailed past the horizon were warned they would fall. Caution keeps us safe. Curiosity keeps us alive. The art of survival is balancing the two. In everyday language, our cosmic messages are mirrors disguised as mathematics. They reveal our self-portrait, a species that loves patterns, symmetry, and the illusion of permanence. The Arecibo message encoded the DNA helix, the shapes of our tools, and the human form. The Voyager records carried Bach, Beethoven, Chuck Berry, and greetings from children. In choosing what to send, we showed what we value: logic, beauty, emotion, diversity. We sent both science and art because we suspect that understanding requires both. A civilization capable of receiving might recognize numbers, but only music would make it kin. Why does this matter? Because the act of sending a message forces us to define who we are. A single radio pulse cannot hold our contradictions, our cruelty, or our grace. So we simplify, curate, translate ourselves into mathematics, pretending that we are one voice. The irony is that this simplification may be the most truthful thing we have done. In compressing our noise into order, we learn what we hope to become. At the human scale, a message is never only about distance. It is about trust. To send one into the dark is to believe the universe can be trusted with our presence. This is not naive. It is aspirational. We act as if the cosmos is kind because the alternative that it is indifferent is unbearable. When we choose to transmit, we practice faith without religion, faith in intelligibility, in shared physics, in the possibility that curiosity itself is universal. Simply put, we are using radio waves as prayer. Each pulse says we are here. We are listening. We have learned to measure time. It says we are capable of cooperation, for even this message required a planet's worth of consensus. It says we are small, but not silent. The power behind those words is not the wattage of the transmitter, but the collective decision to believe that communication is worth the risk. The argument against sending METI, messaging extraterrestrial intelligence, rests on the precautionary principle. We do not know what is out there, therefore we should remain quiet. The argument for it is moral silence assumes fear is wisdom, while communication assumes that knowledge is. Between those poles stretches the entire character of our species. Fear preserves, knowledge evolves. Every culture, every era, chooses its balance. The outcome of this debate will define our next century more than any war or election. It will decide whether humanity's future posture toward the universe is defensive or open-handed. To put it another way, every transmission is a test of self-knowledge. What we send first becomes what we are remembered for. If we transmit only mathematics, we will be known as a species of accountants. If we send only art, we will be known as dreamers. If we send both, we might be known as whole. This is why the next generation of messages, being planned now, combines precision with empathy patterns that encode not just data, but curiosity itself, an invitation to dialogue rather than a declaration of existence. Why it matters beyond science is that these messages remind us how fragile civilization really is. To craft a message for the stars, we must collaborate across nations, languages, and generations. The process itself becomes proof of intelligence, the ability to act collectively without immediate reward. In writing to strangers we cannot see, we rediscover unity we struggle to achieve on Earth. The cosmos becomes not just a destination, but a mirror for our potential coherence. At its core, the real purpose of cosmic messaging may be internal. We send not because we expect an answer, but because we need to hear ourselves speak clearly. The act of encoding our knowledge forces precision. The act of deciding what to omit forces honesty. In the end, the message we launch is less a beacon than a form of therapy, a structured confession from one small world learning how to articulate its place in infinity. Think of it like this: when you shout into a canyon, the echo you hear is shaped by the canyon's walls. The universe is the canyon. The echo, when it returns, will tell us not only about whoever might be listening, but about the structure of space itself, how sound, or signal, travels through it, even if no one replies. We learn something profound: how messages age, how information endures, how hope behaves when stretched across centuries. In everyday language, these cosmic signals are seeds cast into interstellar soil. Most will drift forever, unheard, but some may land where conditions allow understanding to germinate. The time frame for growth is longer than any human life, longer than species themselves. This kind of patience demands a new definition of meaning. Meaning becomes not the expectation of reply, but the persistence of intention. To send is to believe that the future exists. Why it matters at the human scale is because sending messages makes us custodians of time. Every artifact we launch is a promise that knowledge will outlive ignorance. The Voyager record is already our oldest surviving voice, older than any monument will ever remain, long after continents shift and languages die. That small disk of metal will still whisper across the dark, carrying greetings from a vanished Earth. In that sense, our first interstellar conversation is not with aliens, but with our own descendants, or whoever comes after. We are writing to the future across both space and time. At its core, The risk of messaging is the risk of self-revelation. We cannot lie to the cosmos. Physics translates honesty into signal automatically. Any attempt to disguise intent would look unnatural, so we tell the truth, or at least the truth we wish to be remembered for. That act of candor may be our most radical invention. Simply put, each message is a door we open without knowing who stands on the other side. It is both invitation and test. The great silence has taught us that doors can remain shut for eons. But it has also shown us that waiting is itself communication. We wait, and the universe learns that patience is part of our vocabulary. Why it matters philosophically is because communication defines intelligence more than technology does. A civilization's greatness is measured not by what it builds, but by what it chooses to share. To send a message outward is to declare that awareness seeks company. It is a statement of solidarity with all possible minds, known and unknown. At the human scale, standing beside a radio dish under a dark sky feels like standing on the shore of an ocean too large for maps. The dish hums, the air vibrates faintly, and you sense both insignificance and belonging. The night above is vast, but the signal leaving it is precise, fragile, unstoppable. That fragility is beauty, because it means we still care enough to speak clearly, even when we may never be heard. To put it another way, the messages we send are not just attempts to connect. They are experiments in faith, written in the syntax of science. Each pulse of radio is an act of optimism, a refusal to believe that comprehension ends at the edge of our atmosphere. If the universe remains quiet, it is not rejection. It is opportunity. Silence, after all, is the only medium large enough to carry all possible replies. The question we now face is not whether to send, but how to listen to what sending does to us. Each signal we release rewrites our definition of humanity. We become participants in a cosmic dialogue even before anyone answers. The door opens inward before it ever opens outward. We will carry that understanding forward, from the moment of transmission to the long reflection that follows, into a quieter act of awareness, where science meets meaning and the universe becomes less a question and more a mirror waiting for our gaze. The sky no longer feels empty. It feels full of waiting. After all the counting, measuring, and listening, the silence itself has turned into a landscape we know by heart. We understand its folds, its frequencies, its patience. What once seemed like absence now feels like a mirror, showing us our own reflection in wavelengths too wide for the eye to catch. The great silence is not void. It is the atmosphere of maturity, and within that quiet, a new question emerges: what kind of species listens without needing to be answered? We have mapped enough worlds to know that life's ingredients are scattered like seeds. We have learned to recognize atmospheres, to sense the faint heat of alien suns, to see dust swirl around young stars. We have touched frozen rain on Titan and felt warmth under Pluto's ice. We have breathed the first molecules of oxygen made on Mars. These are not random achievements. They are rehearsals. They teach us not just how to explore, but how to exist alongside the cosmos without breaking it. For the first time in our history, our survival depends not on conquest, but on comprehension. At its core, this journey has always been about learning the grammar of restraint. In the age of telescopes, listening has become an ethical act. We are surrounded by data, signals, and light older than life itself. Yet we speak carefully, afraid to echo too loud. Every message we might send into the dark carries both curiosity and risk. Once released, it cannot be recalled. It becomes a permanent artifact, proof that one species, once, was bold enough to call out. The decision to speak is a moral threshold as significant as the first step onto another planet. In everyday language, we are learning to replace discovery with dialogue. Space no longer feels like an object to own, but a presence to converse with. Each mission, each sensor, is a new form of listening. The universe answers not with words but with structure, with echoes of gravity and temperature. Our role is to read, not to demand. That patience is the mark of a civilization still deciding what kind of voice it wants to have. The oldest signals we have sent, radio, radar, stray broadcasts of music and news, are already leaving our sphere at the speed of light. They carry a record of our youth wars, laughter, confusion, art. We cannot edit them. They travel forever. To anyone who might hear, we are already visible, already vulnerable. The question now is what deliberate story we choose to add to that accidental autobiography. The blankness of the galaxy invites sincerity. Our words, if we ever send them, will represent not power but character. Think of it like this. The universe is a vast, dim auditorium, and we are testing the acoustics. We whisper into the dark not to summon applause, but to hear how the hall responds. The echo, when it comes, will tell us something about the shape of space, the patience of time, and the material of meaning. We might not recognize our own voice when it returns. That is the point. The act of calling out changes the caller. Simply put, every signal we craft is a reflection of who we believe we are. A greeting built of mathematics and prime numbers implies a species of logic. A pulse shaped by art implies empathy. A transmission of coordinates implies confidence. Perhaps hubris. The way we speak reveals our assumptions about what intelligence means. When we choose to say hello, we are also defining ourselves to ourselves. Why does this matter? Because the story of exploration has shifted from finding others to justifying our own survival. If no one answers, we must decide whether to continue seeking or to find satisfaction in the seeking itself. The great silence has forced introspection. We can no longer treat the cosmos as background. It has become participant. Its refusal to answer is itself an answer. Grow up, listen longer, and learn to share the sky without shouting. At the human scale, this transformation feels like growing into adulthood as a species. We have moved from awe to inquiry, from noise to nuance. The first explorers looked up and saw gods. We looked up and saw equations. Now we look up and see responsibilities. Our telescopes are no longer extensions of ambition, but organs of empathy. Through them, we sense how fragile both life and observation are. To study a distant world without touching it is to practice restraint, the most complex art of intelligence. At its core, silence has taught us design. We build instruments to capture faint light, but we also build philosophies to interpret absence. The search for company has become the architecture of meaning. Each unanswered signal makes us more careful with what we have. Each uninhabited world makes us cherish the one that breathes. When we found no voices beyond, we finally heard our own layered in noise, argument, and beauty. And, simply put, science and wonder have converged into one discipline: attention. To observe with patience. To imagine without claiming. To measure without erasing, that is the discipline of listeners. The great filters that haunted our calculations may simply be tests of maturity. Those who rush to speak vanish. Those who wait learn to persist. The cosmos rewards listeners with time. Why it matters now is because the threshold we face is moral, not mechanical. We already know how to send messages, build colonies, extract resources. What we must learn is how to do these things without unmaking the meaning of exploration itself. Discovery without reverence is theft. Colonization without gratitude is blindness. Listening without humility is noise. The next phase of civilization will depend on mastering the grammar of restraint. At the human scale, this becomes tangible. The same technologies that read distant atmospheres now monitor our own. The same algorithms that map exoplanets trace pollution on Earth. The same curiosity that drives missions outward reminds us to protect what is near. We are learning to think like a planetary species, one whose health and hope depend on balance. The silence around us is mirrored by the need for quiet within us. Think of it like this: every civilization must eventually decide whether to shout or to listen. Shouting fills the void with the sound of ego. Listening fills it with awareness. We cannot do both at once. The universe, vast as it is, has room for only the patient. If intelligence spreads, it will spread slowly, by signals of trust, not conquest. That realization turns exploration into meditation. Every observation is a moment of stillness stretched across light years. At its core, this stillness feels spiritual. Though it begins in data, there is a serenity in accepting that the universe does not revolve around our noise. To know that light from galaxies billions of years old continues to arrive, indifferent to our presence, is not discouragement, it is belonging. We exist inside a system of laws so stable that even silence has structure. That realization is not loneliness, it is continuity. Simply put, the meaning of all our searching has been reversed. We began by asking, are we alone? We end by realizing that we have never been separate from the universe at all. Every atom in our bodies was forged in the same stars we observe. Every element in our air once drifted through interstellar clouds. We are the universe contemplating itself, a temporary arrangement of matter capable of wonder. To recognize that is to pass through a filter of understanding no telescope can measure. Why it matters is that this insight changes how we act. A species that sees itself as part of the cosmos will treat planets as kin, not prizes. It will listen before it speaks, nurture before it extracts. That is the civilization worth sending a message about, not one that claims to dominate, but one that chooses to belong. At the human scale, we now understand that the quiet sky is not indifferent. It is patient. It gives us room to learn, to fail, and to begin again. The night is not a wall, but a window, waiting for us to stop mistaking reflection for response. When we look at the faint scatter of stars, we are not looking outward, but inward through time. To put it another way, the purpose of the search may never have been contact. It may have been calibration, an experiment designed by the cosmos to teach us how to listen without certainty. If that is true, then the great silence is not a punishment, but a curriculum. Its lessons are humility, endurance, and awe. We now stand in that stillness, carrying the memory of all our questions. We have seen storms of methane and oceans beneath ice. We have mapped worlds where sunlight is a rumor and measured air thin enough to erase breath. Each discovery has expanded not our territory, but our comprehension. The museum of the universe remains dark, yet the flashlight in our hand burns brighter than ever. There is a quote whispered among those who build telescopes: silence is also a kind of answer. They mean that absence can inform as much as presence, that waiting can be proof of worth. In the long dialogue between humanity and the cosmos, we are still at the first word. But that word, spoken or not, already carries meaning. As the final images fade, we are left with a single awareness: the act of listening is itself creation. Each observation writes us into the record. Each unanswered signal proves that curiosity still breathes. The sky's quiet is the sound of a universe giving us time. So the question that remains, hanging beyond every dish and mirror, is the oldest one and the newest when the silence finally breaks. Will we recognize our own voice in the reply?